Hello student. Today going to present the SF&BM lecture 4. Previous class we have already discussed about the shear force and bending moment diagram for a simple supported beam with point loaded. Now today I going to discuss about the simple supported beam, not a simple supported beam, it is a cantilever beam with a point load. How can I draw a SF diagram and the bending moment diagram? Let's see. It is a simple supported beam. Here we can see that it is a one end is fixed and other end is free, and it is the length of the beam is 1.5 meter, and middle of the span the 7,000 Newton act upon it, and the end of the beam is also 7,000 load is acting. In this, how can I draw the SF&BM diagram? First of all, when we draw the SF&BM diagram, first of all you find out the shear forces. How many shear forces are acting? That means 3 point, means end point, middle point, and the fixed point. The fixed means point A. After that, we will find out the BM for different point, then draw the shear force diagram, and after that draw the BM diagrams. Now let's see. Now the how can I how can I find out the shear force at different point? Let's see. Here see that for SF diagram, SF at point, SF at the end point. End point means how much? The 7,000 load acting over it. The SF at the end point is equal to how much? Minus 7,000 Newton downwards, because the force is downward direction according to our sign conventions. Similar way we can find out the at the middle point SF how much? 7,000 end point minus 7,000 same middle point means how much? 14,000 Newton, minus 14,000 Newton at the middle of the spans, and the end and the fixed point means A, point A, how much? No load between the middle span and the fixed point, that means 14,000 minus 14,000 newtons act at the fixed end. There is the SF at point end is minus 7, SF at the middle point minus 14, and also SF at the fixed point minus 1400, 14,000 newtons. So this way we can find out the SF at different point. Now let's see how can I find out the BM for different point. Here we can see that it is a simple supported beam, and BM at the fixed point is equal to how much? BM at the fixed point is equal to how much? About the fixed point, BM equal to 0. Then force into perpendicular distance is equal to BM, means force 7,000, and BM is equal to how much? 7,000 force into distance equal to how much? Distance is equal to 0, means BM at the fixed BM at the end point equal to 0. Again, here see that the distance between the fixed free end to the middle span is 0.75. Then BM at the middle of the beam is equal to how much? Force is equal to how much? Left side and right side from the this sections, minus 7,000 minus, and distance 0.75 means minus 7,000 into 0.75 is equal to how much? We can easily calculate the value. The value is 5250 Newton into meter. Then similar way we can easily find out the BM at the fixed end is equal to how much? The right hand side of the right hand side of the sections, 7,000 at the distance from the point, so at the fixed point means 7,000 minus 1.5 is equal to how much? You can easily find out by simple calculations, 10,500, and again middle of the load 7,000 into 0.75 is equal to how much? Minus 5250. Why it is minus? Because downward directions you have already discussed about the sign conventions. So BM is equal to minus 10,500 minus 5,250, then it is 15,750 Newton into the meter. This way we can easily find out the BM at the different points. Now now after that we can draw the diagram. It is very essential for this shear force and bending moments. Now let's see how can I draw the shear force diagram. It is a cantilever beams, and the load at a free end 7,000, and middle of the span is also 7,000 newtons, and fixed end A, and distance of the beams is 1.5 meters. Now for SF diagram, here we can draw a perpendicular line from point A and different where the load is acting over it, like point draw a perpendicular line from point A, also draw a perpendicular line point 7,000 middle of the span, and also the draw a line the end of the beam. After that we have already find out the different value for SF, and also find out the different value of BM. Then for SF diagram, here you can see that the free end, at the free end, what is the value of the SF? Already find out, minus 7,000. Then again we can take a any scale. Let minus 7,000 is equal to how much? Minus 7,000 is equal to means 5 centimeters, or this line. Then draw a perpendicular line from the free end, and the value is equal to minus 7,000, and there is no load between middle of the spans and the end. That means draw a parallel line, just draw a parallel line up to the middle of the span. Again middle of the spans also act the 7,000 load, and already find out the SF value is how much? Minus 14,000. And if the scale is 5 units, then how much the scale is 14,000? Means 10 units. Draw a 10 units on the scales from a vertical line, and again no load between the middle of the span and the point fixed end. There is a again try horizontal line, and this box equal call for SF diagram for the cantilever beam. This way we can draw the SF diagram for a point loaded at different at different sections and different locations. We can easily draw the SF diagram in this way for a cantilever beam. Now let's see the BM diagram. How can I draw the BM diagram? Before I going to draw the BM diagram, BM diagram must be draw the below the SF diagrams. So BM diagram must be draw the below SF diagram. Let's see how can I draw the BM diagram. We have already found out the different value for the BM diagram. Now let's see what is the BM. Here we can see that in BM diagram there is a perpendicular line from the point free end and the middle of the space and the fixed end, and the measurement is always same. uh, then if the BM, already find out the BM at the free end is equal to how much? BM at the free end is equal to 0, that means no scale means 0 point. After that BM at the middle of the spin is equal to how much? BM at the middle of the spin is equal to how much? Distance into already find out the load into perpendicular distance. The value already we have find out, the value is 5250 Newton into meters. In downward directions mean negative sections. And again we find out the BM at the point A is equal to how much? We have already find out the value, and minus 15 15,750 the value, the BM. Then draw a straight line from fixed end to middle, and again draw the straight line from middle to the fixed end A, straight line. This diagram is called the BM diagram for the cantilever beam. Here we can see that in previous class we have already seen that the in simple supported beam, BM is always upward direction, means positive, but in cantilever beam BM always the negative means negative direction, means negative. We have to remember that the simple supported beam BM is always positive, and the cantilever beam is BM always negative. So it is a SF diagrams, SF and BM diagram for a cantilever beams. Thank you student, and next lectures we can see more problem in the
cantilever beams, like more point loaded hands UDLs also. Thank you.